All right, subscribers, welcome back. Today what we're going to be discussing is thermochemical equations in a little bit more detail. So what we have here is our standard enthalpy of vaporization and fusion. And we need to be able to distinguish these two from one another. And so what we have in problem number 1 is it says use the table above to determine how much heat is released when 1 mole of gaseous methanol condenses to a liquid. So we have to take some things into consideration. One, what are we working with? And the answer to that is gaseous and liquid methanol. So we're dealing with this condensation of gaseous methanol, which would look like this, CH3OH, which is a gas. And if it condensates or condenses to a liquid, we would still have methanol here. We've just gone through a phase change, but now we would have a liquid. And so the answer to this, or the question is, okay, if we have exactly 1 mole of methanol gas and it consolidates down to our methanol as a liquid, how do we determine how much heat we have? Well, the good thing is we have this nice chart and we also have 1 mole. So just like we started with stoichiometry problems, we would have 1 mole of CH3OH. And then we would set up our conversion and we would cancel out moles of CH3OH on bottom. And what we're trying to get to is kilojoules of heat. So we put kJ on top. Now, for methanol, we can see that there are 2 different values. So for these values here, we need to figure out which one we want. Okay, so vaporization is when heat is needed to go from a liquid to a gas, and fusion is when the heat is needed to go from solid to liquid. So think to ourselves, okay, I have liquid to a gas and solid to a liquid. Which deals with the same state of matter? Well, the answer should be our liquid to gas or gas to liquid. Okay, so we're going to be using this chart right here for this particular problem. And now we need to talk about our value here. So we have 35.2 kilojoules per mole. So that means here 1 mole releases or gains 35.2 kilojoules, okay? And so 35.2 is going to be associated with kilojoules. And then on bottom, it's for every 1 mole. Now, what we need to think about here is this. All right, if we're condensating, are we releasing or do we need to take in heat? Well, the answer to that question is we are releasing. So that 35 number needs to be negative. Okay, so this calculation should be pretty easy. Most of you can probably see it, but all we do is take 1 times negative 35.2. We press enter, and we get a value of negative 35.2. So that means that negative 35.2 kilojoules of heat is released when we have this condensation of exactly 1 mole. Now, what I have done is made this relatively simple, and in reality, you're probably not going to have 1 mole of something. So now we're still dealing with our substance here. We're dealing now, with ethanol, and so now we are going to have to figure out how much heat must be supplied to melt ethanol. Now, melting goes from a solid to a liquid. So with this, we need our methanol, which in your chart there is C2H5OH, which is a solid, and it's going to melt to our liquid methanol. Now, here is the problem, and I should put the state of matter. We get 4.60 grams. This chart gives it to us our delta H values in kilojoules per mole. So we first need to take 4.60 grams of our ethanol, and we need to convert that to our moles of ethanol. Now, with this, we need to first cancel out our units of grams of ethanol, and on top, we can get to moles of ethanol. Now, you can look up ethanol, but to save us some time here, ethanol has a molar mass of 46.07 grams per mole. The 46 number is associated with grams, so it goes on bottom here. And on top, we put 1 mole. Now, we need to get rid of moles and talk about heat. Okay, so moles of methanol is going to cancel. And then on top, we can get to heat, which we use the unit of kilojoules. So when we melt something, we need the delta H of fusion. So ethanol's delta H of fusion is 4.94 kilojoules per mole. Okay, so what that means is every 1 mole, there is 4.94 kilojoules of heat released. And I'm going to write this above. 1 mole equals 4.94 kilojoules. Now, again, 1 is associated with moles, 4.94 is associated with kilojoules. And so what we do here is this. We need to think about the sign. If we're melting something, do we put heat into, or do we take heat away from that particular substance? Well, the answer to that is we need to put heat in, so that is a positive 4.94. Okay, so what we do here is we take 4.6 divided by 46.07. I'm going to press enter. Then I take that number and multiply it by 4.94, and I press enter. So the amount of heat that is needed is a positive 0.493 kilojoules of heat, and that would allow us to melt our 4.60 grams of ethanol. All right, so we need to use this type of idea to answer the other questions that are located on this particular sheet. Hope you have enjoyed these 2 problems. They're really helpful. And as always, if you haven't done so already, make sure you subscribe.